All right, so we are on 6.3, so make sure you're pulling up the 6.3 note sheet from Schoology. We're going to be looking at some airplane and vote vector problems here. So when we're looking at a problem like this, kind of want to get you used to looking at the angles here and how we do these. So just like our other problems, we've been always measuring those from the horizontal right here. So if we've got 30 degrees northeast, that kind of tells you where the direction here is. And so northeast is over here in this quadrant 1 area over here. So 30 degrees would be from the horizontal here. So this is your 30 degrees. So we got that one. So then the next one there says you've got 70 degrees northwest. Well, northwest is over here in quadrant 2, so you want 70 degrees from here. So this would be your 70-degree angle. And then if they ask you to go ahead and find 80 degrees southeast, well, southeast is down here in quadrant 4. So 80 degrees from the horizontal here. So this is 80 degrees. So kind of get you used to looking at what those would be. And then, of course, we could put another one on here. Let's make a fourth one while we're at it. And let's say 10 degrees southwest. So 10 degrees southwest. Again, from the horizontal, we're over here in quadrant 3 now. So 10 degrees here. 10 degrees in this region right there. So get you used to measuring those angles from the horizontal like we've been talking about, always from the horizontal. So first example here, an airplane is flying 350 kilometers per hour in a direction of 30 degrees northwest. The wind is blowing at 60 kilometers per hour in a direction of 70 degrees southwest. Find the magnitude and direction of the resultant vector. So kind of going to draw out a picture here, and I'll do kind of a whole picture, and then I'll kind of pull it apart as well. So let me draw out my little coordinates here. So this is north, south, west, east. So it says an airplane is flying 350 kilometers an hour in a direction of 30 degrees northwest. So let's do that northwest here and 30 degrees. So this is 350 kilometers per hour. And this ends up being my 30 degrees northwest. So this time we're looking at not, number of miles, we're looking at the rate that they're flying there. So that's the magnitude there. And then our direction, of course, there is our 30 degrees. And then we've got something that's impacting the airplane here. The wind is blowing at 60 kilometers per hour in a direction of 70 degrees southwest. So now, at the end of this part, I'm going to go ahead now and impact the wind blowing here is 60 kilometers per hour. So kind of think of this as another north, south, west, east sort of a thing at the end there. And it says southwest. So 70 degrees southwest, remembering to put your angle in there. So that's 70 degrees in there. And then what we really want to figure out is, so this is your 60 in here. And what our goal here to figure out is what that there is. So we want to know the coordinates as we go over and then up. So we want to know what A is and what B is, and we'll have to get the magnitude as well. So get our coordinates there, and then we could name the angle and the kilometers per hour. So to do that, you can just go ahead and draw them out here separately. So when I think about this, I'm going to think about the airplane, and I'm going to do the vector coordinates for the airplane here. So kind of to blow that back up here. So it was Drawing out my little triangle here from the original one here. And our angle in here was 30 degrees. So if we can figure out here what A and B here are, then we'll have the vector coordinates for that. So I'm just going to call that vector U. So to be able to figure that out, I'm going to figure out my cosine and my sine values again, just like we've been working with all along. So if I want to set that up to find A here, I can say, oh yeah, the cosine of 30, because this is A there is my adjacent and 350 there is my hypotenuse. So working with those, I can say cosine is equal to my adjacent over my hypotenuse. Multiply across. So A ends up being 350 cosine 30. And then to find B here, because I need the components for this. So I got 350 cosine 30. So I'm getting 303.1. Remember, your calculator has to be in your degrees because we're working with degrees here. So notice we're going over here in the second quadrant over here. So we're going negative for A and then positive for B. So we're going over negative and then up B. It has to be positive. So this is negative. Make sure you do that because it's going to be the number one mistake is your negatives and your positives on the test. So then opposite and hypotenuse here, it'd be sine 30 over B equals, oops, it's not sine 30 over B. It's sine 30 is equal to my opposite, and my opposite is B, and my hypotenuse there is 350. So I get B equals 350 times the sine of 30. So now I could just figure out what B there is. I can plug it in my calculator, 350 sine 30 there. And when I do that, I get 175. So we said B had to be positive for the airplane. So now let's look at the wind's impact on this whole thing. So I'm going to come down here now and look at the wind. I call that vector V. And that triangle there, drawn out there, we have, it looks like this. You're going over, looks like this. This is your A, this is your B, your resultant is a 60. And then we got our angle in there. Our angle there, we said that was 70 degrees, I believe. Yes, 70 degrees. So let's go ahead now and work with the wind here. So determine what that value there is. So components here again, so cosine 70. Your adjacent is your A. Your hypotenuse is your H. So A is 60 cosine 70. And then I can do the same thing with my sine. To get B there, I have to use sine of 70 equals my opposite, which is B, over my hypotenuse there, which is 60. So I can do B equals 60 sine 70. So let's figure out what those values are. Just go ahead and plug those into your calculator there. So we're getting 20.5 here. And notice for this one here, you're going to the left negative and you're going down negative. So it's got to be a negative negative. So over here, we went over there in that portion over there, we went negative and then negative. So I got to make sure that I write those down. And then same thing here, we got 60 sine 70. And when I do that, I get 56.4. It also has to be negative. So negative 56.4. And again, that's because when we were over there in the very original here, we went over so much and down so much to get our resultant there. So this was our A and our B up there. So A, we went to the left, and then B, we went down. So those are our vector components there. So now let's find our ending parts here. So to figure out the resultant vector, the real final values here, we can take vector u plus vector v. So the components of vector u there are negative 303.1, and we've got a 175, and then we're going to add vector v there is negative 20.5 and negative 56.4. So remember, when you add your vectors together, you add your horizontal components, and then we can add our vertical components there. So if I take negative 303.1 and I add negative 20.5, and then I take 175 and I add a negative 56.4, I will end up getting my vertical and horizontal components there. So I end up getting negative 323.6, and I get positive 118.6. For a minute there, I thought it was wrong. But no, that's correct. 175 plus a negative 56.4, that's 118.6. All right, so that gives us our components. We still haven't answered our question about magnitude and direction. So the magnitude here, remember, they gave you these components. This is like your A and your B here. So we go ahead and we got to actually find out our C, or our hypotenuse of this. So you can take negative 323.6 squared plus 118.6 squared, and then take the square root. And when I do that, I get 344.6 kilometers per hour. That is the magnitude. Now we got to go ahead and figure out the direction, and that's going to give us, that's going to be our angle. So we're going to do, let me show you if I draw this out. So your resultant vector ends up being, we got a negative, so negative goes this way, and then you got a positive which goes this way. So you got negative 323.6 and 118.67. So your angle is over here. So I'm going to set this up. This is my opposite and this is my adjacent. So because I have those, I'm going to use tangent, because opposite over adjacent there is tangent. So I can do the inverse tangent of 118.67 divided by negative 323.6. And usually I get in the habit of always doing this and always kind of like not putting the negatives or positives in here. I just put them in there as is, because your angle there, we always want it to come out to be a quadrant 1 angle, sort of. I mean, it's really over here, but it's always going to be an angle over here is going to be less than 90 degrees over there. So I just put in the positive value. It just makes it a whole lot easier to not get anything ruined when I actually have my last answer. Or otherwise, go ahead and put the negatives in there, that's fine. It's just easier to put the positives in there, because then you'll always get the correct answers. You won't have to figure anything out. So I always put them in there. So 20, and I'll go out to the nearest tenth here as well. So 20.1 degrees there. And we also know, because of our coordinates here, our vector coordinates there is a negative and then a positive. We know we're over here in quadrant 2. So if we're in quadrant 2 there, we know that we have to be in the direction of northwest. Or some of you might say quadrant 2. So this, this are all good parts of your answer there, all parts of your answers.